This is my trigonometry course. Today you're going to prepare for the third test of the course. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. I've said it before, I'll say it again. There are some subjects where you can study the night before for an hour and you'll get a perfect score on the exam. Math doesn't work that way. You need at least 2 or 3 days to prepare for a math test. But it doesn't matter how many times you tell students to study for a test, they're not going to do it. So in order to force you to do at least some studying, we're going to do a practice test together. And I'm going to give you a practice test for homework. And these practice tests will not only force you to do at least some studying, but they'll also familiarize you with the format of the test, so you can't say that you were caught off guard. This is the information that you need to memorize for this test, so you can take note of that. And as we work through this practice test, I want you to try the problems on your own first. These first problems we need to do without a calculator, although you will need a calculator for the test. In these first problems, see if you can do number 1 without a calculator, and don't just watch me do the problem. You want to try it on your own, and if you can do it, that means that you may know these problems pretty well. If you can't do it, that tells you that of course you need to focus on these problems when you study for the test. And if you get stuck, that's okay. We haven't done these problems in maybe a week or two, so that's perfectly fine. The purpose of a practice test is to get your mind jump started with this material. So try number 1, and when you come back, we'll do it together. Okay, we're back. Okay, so this expression represents an angle. So I'm going to set it equal to theta. And by definition, if that's true, then that means tangent theta is equal to 1 over root 3. So again, that's a definition, and we're looking for the theta value that makes the equation true. So in order to figure out what the theta values are going to be, we're going to draw our triangles in standard position. If tangent is positive, then the legs of the triangle both have to be positive, or they both have to be negative. And we recognize that ratio, opposite over adjacent, and our values will be negative if our triangle is in the third quadrant. So negative actually that would be over here, and negative x root 3. Okay, so again, this is a special triangle. The angle measure opposite x is 30. And so that's one possible option, and then we have another option where the angle measure is actually 210 degrees. Now the reference angle is still 30 degrees. Same triangle, it's just in a different quadrant. So the big question is, what is the angle that we're looking for? Well, we can actually have an infinite number of angle measures. So this picture is just showing 2 possibilities, but remember, we're looking for the tangent inverse, or the value of the tangent inverse expression, and we've got limitations for what tangent inverse can be. Look down here, or actually up at the right. Tangent inverse has to be between negative 90 degrees and 90 degrees. So that means that the answer has to be the green 30-degree angle in the first quadrant. there terminates in the first quadrant. So theta has to be 30 degrees. So we can write a final answer here, tangent inverse of 1 over root 3 is equal to 30 degrees. So there you go. If you got that right, excellent. Try number 2. When you come back, we'll do it together. Okay, we're back. So again, this expression represents an angle, so I'm going to set it equal to theta. And by definition, if that statement is true, then this statement also has to be true. So all we have to do is find theta when the secant function is equal to -1. But this is a collapsed triangle, so we can't draw triangles like we did over here. It's a collapsed triangle. So what do? Well, we go to the secant curve and ask where is the y value 1, or what point on the graph, the red graph, has a y value that's equal to, or not 1, -1. We're looking for a y value where it's -1. Secant theta is equal to -1. So this point here has a y value that's -1, and this point also. But again, if we go to our inverse function range restrictions, you see that y has to be between 0 and 180, not including 90 degrees. Now it can be equal to 180. Notice it includes 180. So our answer cannot be -180. It has to be positive 180. So that is the answer. Theta has to be equal to positive 180 degrees, so we can say finally secant inverse of -1 is equal to 180 degrees. So there you go. If you got that right, very good. If you're having trouble with these, that's totally fine. That's okay. That just means that you have to do more studying for the test. It's okay. That's the way that all students feel when they have to study for a test. You get this sinking feeling like, I don't want to do this, but you're going to do it anyway. Okay, problem number 3. Go and attempt number 3. When you're back, we'll do it together. Okay, we're back. This is a calculator problem. Go to your calculator, push the mode button, make sure you're in degree mode. That's if you're using a TI-84 Plus. If you're using a TI-84 Plus, push the blue second button at the upper left, then the sign button at the middle upper left, and then 2 divided by 3, and then the right parenthesis button, and then enter. You don't have to write the right parenthesis button, or you don't have to enter it. So we need an approximately equal to symbol because this is an approximation, and we're supposed to round to the nearest tenth, so 41.8 degrees. Now if you're using a iPhone, you want to make sure you're in degrees. Press your iPhone button, or your iPhone calculator. Open your iPhone calculator app, rotate to landscape mode, and at the bottom left it should say rad. If it says rad, that means you're in degree mode. If you push the rad and it says DEG, that means you're not in degree mode because a rad symbol appears at the upper left. Very confusing. Very confusing. So you want to enter 2 divided by 3 in your calculator, your iPhone, and then push the second button at the upper left, and then the sign inverse, sign -1 button, and you get 41.8. So again, you shouldn't really be using an iPhone in this class. You should have a graphing calculator in this class, but if you got that right, excellent. So now we're given graphs and asked to find the equations of those graphs. Now, this is a sinusoidal graph, which means that you can represent this graph with a cosine function, a cosine equation, or a sine equation. But it says up here, always use the sine equation or the sine function. That way, when you check your answer, we'll have the same answer. So notice it says general form of the sine function, and we actually have to write that. So I'm not going to give you that for the test. I want you to memorize that. So you're going to have to memorize this information here. You see the red and the purple and the green up there? You have to remember what phi and omega and b and a represent and how to find all that information. So let's write the general form of that equation. So y is equal to a times sine omega x minus phi plus b. Now the midline equation is the equation of the line that's right in the middle of the graph. So where's the middle of the graph? Well, the middle of the graph is obviously right here. Usually we use a orange dotted line. That's this line here, and you can see that's y is equal to -1. It's right below the x-axis. So y is equal to -1. What does that mean? It means that b is actually equal to -1. So we have b. Now the amplitude is the distance from the midline, which again is this orange line, to the top of the hills, or you could say the bottom of the valleys. So that's 1, 2 units, or you can go up 1, 2 units. So the amplitude, which we call capital A, is 2. And to find omega, we need to use our equation for the period. The period of a sinusoidal curve is equal to the normal period divided by omega. So if omega is 1, then the normal period would just be 360 degrees. But omega is not going to be 1 in this case. Well, maybe it is. We'll have to see. So now what we need to do is find the period, and we can do that just by looking at the graph. We see here that we have 1, 2 boxes, and each box, we're told in the directions, represents 90 degrees. And each horizontal, or excuse me, each vertical unit is represents one unit in the vertical direction. So we have 2 boxes, so the period is 180 degrees horizontally. So again, that's the horizontal distance. 1, 2 boxes, so that's 90, and then 180 is the period. That's the horizontal distance before you have one complete cycle. Horizontal distance required for one complete cycle. So now we can multiply both sides of the equation by omega. There's a lot of different ways to solve these types of equations here, but that's how I do it. And then divide both sides by 180, and we end up with 2. So now we have omega. Omega is 2. Now if you want to show some of that algebra, you can show it, but you don't really have to show it. If you wanted to demonstrate some of that algebra, you would multiply both sides by omega, and then we go to the next step of the equation and divide both sides by 180 degrees. Okay, now let's find the phase shift. The phase shift is equal to phi divided by omega. So we know what omega is. We can go ahead and plug that in. So the phase shift is the horizontal translation. Normally the sine curve starts at the origin, but you can see that it's moved over 90 degrees to the left. So see that distance there, 90 degrees to the left. So the phase shift, we can see just by looking at the graph, is -90 degrees. if we multiply both sides by 2, we can see that phi is equal to negative 180 degrees. So at this point, we're ready to write the equation that we've been looking for. So this is the general form of the equation up here. Y is equal to A, which is, we found A is 2, times sine omega, which we found is 2, x minus plus b, and b is negative 1. So I need to make a negative there. Okay, now we can just write it in simplified form. We have a double negative, and there you go. So that is the equation of that graph. So again, we're looking for the equation of this graph, and we found it. Okay, if you got that one right, excellent. Go ahead and try number 5. Now, this is obviously going to be either a secant graph, a secant function, or a cosecant function. But the directions tell us to always use the cosecant function when we are writing our equation. That way, when you check the answer, you'll see the same answer that I get, and you can verify that you did it correctly. So you can take a screenshot of the directions up here and go ahead and try problem number 5, and when you come back, we'll do it together. Alright, we're back. So again, I'm not going to give you the equation or the general form of the equation, but I'm going to write that now. You'll have to memorize this. So that's the general form, and the midline you can see is down at negative 1. Same line that we saw in the previous graph. That's just a coincidence that we're seeing that again. So that tells us that b is negative 1. Now, we don't call a the amplitude anymore. We only call it the amplitude when we're dealing with sinusoidal functions. That's the cosine function or the sine function. But a still has a meaning. It's the distance from the midline to the graph, the shortest distance. Or if you want, you can go down and you'll get the same number. It's going to be 1. So in this case, a is going to be 1. In the previous problem, a was 2. And we called it the amplitude. But not in this problem. So to find omega, we're going to use, again, the equation for the period. And the normal period is always written up here. For the sine, cosine, secant, and cosecant functions, the normal period is always 360 degrees. That's assuming that you don't compress or stretch the graph horizontally. The normal period for the tangent and cotangent functions is not 360. It's 180, so that's something that you're going to want to memorize. That is written down here. So this is the equation for the first 4 functions, and this is the equation for the last 2, the tangent and cotangent functions. So let's look at what the period is. The period is the horizontal distance for one complete cycle. So we'll start here. We could start anywhere, but I'm going to start there. And then we go 1 box, 2 box, 3 box, 4 boxes. So the normal period is 4 times 90 degrees, which is 360. Or the period for this graph is 360. So obviously omega is 1, because it turns out that the period for this function is the same period that you would get with the normal cosecant function. So now let's use the phase shift equation. The phase shift is equal to phi divided by omega. And you might wonder, well, how am I going to remember that? Well, you're just going to remember it. That's one of the things that you have to do for the course. Now the phase shift is, again, well, if we're dealing with the cosecant curve, normally the cosecant curve would be here. But as you can see, it's moved horizontally. It's moved vertically also, but horizontally it's moved 2 boxes to the left. So that's negative 180 degrees. Each box is 90 degrees. If you move to the left 2 boxes, that's negative 180 degrees. So that's the phase shift. Remember, the phase shift is the horizontal movement from the parent graph. We're looking for phi, and omega is 1. So phi is equal to negative 180 degrees. So now we're ready to write our equation. A is 1, B is negative 1. So we have 1 times cosecant. Omega is also 1. Phi we just found is negative 180, so actually we're going to have a double negative. And B is negative 1 again. So these constants just happen to be similar for these two problems. Let's double check and make sure we wrote everything correctly. Everything looks right, so now we can simplify that. So y is equal to cosecant x plus 180 degrees minus 1. So if you got that right, excellent. Okay. So on to the next problem, try number 6. Remember, we assume that A is 1 whenever we have a cotangent or tangent curve, because it would complicate things if A were not 1. And remember, if the curve is in this orientation, it's going to be the tangent curve. If it's in this orientation, it's going to be the cotangent curve. And I tell you what the curve is going to be up here, so you don't really even have to guess what that. So try number 6, and when you come back, we'll do it together. Alright, we're back, so let's write the general form of the cotangent curve. Excuse me, the tangent curve. As you can see, the general form is very similar. That's pretty much the same in terms of the equation. The only difference is the function is the tangent function now. So B represents the midline. So the midline in this case is going to be right on the x-axis. So the equation of the midline is y is equal to 0. And that means that B is 0. We're assuming that A is 1, so we don't really need to do anything with that. Now we're going to use a different formula for the period so we can find omega. The normal period of the tangent curve or cotangent curve is 180 degrees, so be aware of that. So now we can look at the period. What is the horizontal distance necessary for one complete cycle? Well, you can look here. We have 1 box, 2 box, 3 box, 4 boxes. So that's 360 degrees. 360 degrees necessary for one complete cycle of the curve. And if you do the math, you're going to end up with 1/2 for omega. So this is the first time that we got a fraction for omega. So the phase shift is always equal to phi divided by omega. And let's look at the phase shift. Normally tangent would look something like this. It would go through the origin, but now it's not going through the origin. It's shifted 1-2 units to the left. But you can also think of it as being shifted 1-2 units to the right. So it just depends on how you want to think about that. We've already shifted to the left in the two problems previously, so I'm going to shift to the right, and the solid curve here is what we're focusing on. So that's an important thing to note for the test, as we're talking about the solid curve. So the phase shift was actually positive 180 degrees, and omega is 1/2. So we know that it's 180 because there's two boxes shifted to the right, two boxes. Each box is 90 degrees. Okay, so if we multiply both sides of the equation, maybe I should show that because students may get a little anxious about having to deal with a complex fraction here. We're going to multiply both sides of the equation by 1/2, and we get 90 degrees is equal to phi and we get 90 degrees is equal to phi. The 1/2s cancel out here when you multiply, and 1/2 times 180 is obviously 90 degrees. So now we're ready to write our equation. So y is equal to a, which is assumed to be 1 for the problem, times tangent. Omega is 1/2. Omega times x minus phi, which in this case is positive 90, plus b, and b in this case is 0. We found that b is 0 in the first step. So plus 0, and let's write the final form. And there you go. All right, so if you got that one, good job. If you had a little trouble with those, that's okay. Again, the purpose of this practice test is to help jumpstart your brain, and you can kind of get a feel for what you need to practice and what you need to not practice, because you don't need the review. Okay, now we're going to move on to the law of sines and the law of cosines. So it says find the missing side lengths and angle measures of each triangle. In other words, solve the triangle. That's what it means to solve a triangle, to find all the side lengths and angle measures. And notice it says there might not be a triangle that exists for some of these problems. Now if I draw the shape of the triangle here, well, obviously it exists because I was able to draw it. But in some of these problems, I'm not going to draw the triangle, and in that case, the triangle actually might not exist. But it could exist. So problem number 7 is to find the measure of angle C, and that's going to be pretty easy because we can just use the triangle sum theorem. And by the way, this is an AAS scenario. That's probably the first thing that we should note. It's an AAS scenario. So what does that mean? It means that eventually we're going to use the law of sines. Here's your scenarios. We have an AAS scenario. Whoops. That's this scenario here, and that means we're going to use the law of sines. We don't have to worry about ambiguity because we're not looking for an angle using the law of sines. Whenever you're looking for an angle using the law of sines, you always have to worry that your calculator may give you the wrong number. Okay, so the measure of angle A is 114 degrees, measure of angle B is 36 degrees, and we're looking for the measure of angle C. And don't be afraid to use your calculator for this. We get 30 degrees. So that is one of the answers. Well, actually, that's the answer for number 7. So we're done with number 7. On to problem number 8. We're looking for lowercase a now. Now, again, we have the AAS situation, so we have to use the law of sines. If we're looking for side A, obviously we're going to use sine A over A. And we have side B, so we better use sine B over B because we have that information. So the measure of angle B is 36 degrees. The length of side B is 9. And the measure of angle A is 114 degrees. And the length of side A, well, that's just A. And remember, there's a lot of different ways that we can solve this. The fastest way is probably to use cross multiplication. So if I multiply these, I get 9 times sine 114 degrees. And if I multiply these green ones, I get A times sine 36 degrees. Well, then we're going to divide both sides of the equation. And by the way, you don't have to show all this work. You can actually just do the algebra in your head. And I'm not going to show all the work each time that we do this, because that would get pretty tedious for you to have to watch. Because it's the same algebra every time, pretty much. Well, there are some variations of these problems. If you're looking for an angle, then the algebra is going to be actually easier. So A is equal to 9 times sine 114 degrees over sine 36 degrees. So let's use our calculators. 9 times sine 114 degrees, enter, and then divided by sine 36 degrees, enter. So we get 13.9879. And the units are inches. A lot of students are going to forget to write inches. If you forget to write inches, then you're going to lose points. So now we're going to find the length of side C. And when you're doing these problems on the practice test, be sure not to skip this problem up here. So to find the length of side C, we're going to obviously use sine C over C because we're looking for side C. And we want to stick with sine B over B because that those numbers are not rounded off. You want to avoid using rounded off numbers if you can. So the measure of angle C we found, that's that purple angle up there, and the length of side C is what we're looking for, and the measure of angle B we're given in the problem is 36 degrees, and the length of side B is 9 inches. We're given that in the problem. So again, I'm not going to show the algebra every time that we do this, because I don't want to bore you. But if you solve for C, you should get the following. And then we can go to our calculators. 9 times sine 30 degrees, enter, and then divided by sine 36 degrees, enter. And I'm going to write that 36 a little more legibly. So we get 7.6558 approximately inches. So the problem doesn't tell us what to round off to, so we can use our own discretion. And technically, if we're going to round, that should be a 9. Okay, so we solved that triangle, and we did 3 problems in the process. So I know that seems like a lot of work, but it wasn't just one problem, it was 3 problems, so be aware of that. Okay, so that was the AAS situation. Now we're going to the ASA situation here. When you have an ASA situation, you're going to use the law of sines again. So we know we're going to use the law of sines, but first we can use the triangle sum theorem to find the measure of angle B. Measure of angle A is 87 degrees. We can see that in the triangle. The measure of angle C is 70 degrees. We can see that in the triangle. And you can use your calculator to find these numbers to avoid any arithmetic errors. A lot of students would say, well, why do I have to use a calculator for that? I can probably do that in my head. You can, but doing it in your head increases the probability that you'll accidentally get the wrong number, and that would not be good, because that would mean all 3 of these problems will be incorrect, and that's a pretty big blow, given that there's only 25 problems on the test. So we get 23 degrees for B, and that's problem number 10. Now on to problem 11. We're looking for the length of side A, so obviously we're going to use sine A over A, and we're going to have to use the measure of angle B, because that's the only other angle that we have, and we do have the length of side B. So sine 23 degrees over the length of side B, which is 6.4 millimeters, is equal to sine A, which is 87 degrees, over the length of side A, which we don't know. So let's do the math. We get 6.4 times sine 87 degrees over sine 23 degrees. So 6.4 times sine 87, enter, divided by sine 23, enter, and we get 16.3571. 16.3571 millimeters. Again, make sure you write your units. These problems don't tell us what to round off to, but when you're using the law of sines or cosines, it's always best to carry 4 decimals, or 4 digits to the right of the decimal. So now we can find the length of side C. Obviously we're going to use sine C over C, and sine B over B. So we know the measure of angle C is 70 degrees. We don't know side C, that's what we're looking for. The measure of angle B we found in the first step is 23 degrees. And the length of side B, we know, they gave us that, is 6.4 millimeters. So solving, doing the algebra in our head, we get the following expression. And we can go to the calculator. If you're using an iPhone, you're going to enter this in completely differently than if you were to enter it into a graphing calculator, so be aware of that. So we get 15.3917. 15.3917 millimeters. Again, I don't mean to sound like a broken record, but write the units, or else you're going to lose points. Teachers love to take off points for not writing units. Okay, so we're done with another triangle there, and we did 3 more problems. So we did 6 problems total out of the 25 for the test with these 2 triangles. We solved both of those triangles. This was the AAS situation where we used the law of sines. This is the ASA situation where we use the law of sines again. And as you can imagine, now we're going to use a different law, the law of cosines, because we have the SSS situation. Okay, so we need to find all the angles of this triangle because we have the sides. And when you have the SSS scenario, meaning you have all the side lengths and none of the angle measures, you use the law of cosines. And there are 3 versions, which are pretty much the same law, same equation, just applied to the different sides. We're going to use, we're looking for the measure of angle B, so we're going to need a cosine B at the end of the equation, which means we need B squared at the left. And because B is on the left side, A and C are going to be on the right side of the equation. And I guess I didn't need as much room as I thought there. So there you go. That's the law of cosines if we're looking for angle B. So we know side B is 20. And side A is 10, and side C is 13, and side A is 10 again, and side C is 13. Now, notice that we're finding the measure of angle B first. The reason we're doing that is because when we find this angle with this equation, and that's really important to understand, is that this equation is going to give us the right answer. This equation always gives us the right answer because it factors in every side of the triangle, which means that this angle that it gives us is only going to represent it's going to be the only option for the angle. The calculator is never going to give us the wrong angle when you're using the law of cosines. And because this angle, if it is an obtuse angle, then it's going to find it for us. But if it's not an obtuse angle, that means we're not going to have to worry about our calculator giving us the wrong number. And we can see that this is an obtuse triangle just by looking at it, but sometimes, in fact most of the time, you're not given a picture of the actual triangle. So we have to solve this equation. And this is a trigonometric equation. The most important thing is to write the equation, plug in all the numbers, and after that I don't really require you to show me the algebra. But we're just going to show the algebra here so you know what we're doing. So 400 minus 269 is 131. Then we're going to divide both sides by negative 260. And we get negative 0.503846 approximately. And you can keep that number in your calculator. So I'm going to write 3 dots, meaning keep that number in your calculator. And now we're looking for the measure of the angle, so we use cosine inverse notation. And again, we want to write 3 dots, meaning keep that number in your calculator so we don't have round off error. So what you're going to do with the iPhone is you can just press the cosine inverse button and it'll give you the answer immediately. With the TI-84 Plus, or pretty much any Texas Instruments calculator, you're going to press the blue button at the upper left, the second button, and then the cosine button. Then you're going to push the blue second button again, and then the button at the bottom right with the negative symbol in the parentheses, and then press enter. And we get 120 degrees. 120.25479 degrees. So we know that that's an actual angle because we use the law of cosines to find it. And there can only be one obtuse angle in a triangle. It's impossible to have more than one obtuse angle because, think about it, an obtuse angle has a measure that's greater than 90 degrees. But if you have 2 angles that are, say, 91 degrees, then you'll get 182 degrees when you add them up. That's impossible for a triangle to have angle measures that add up to something bigger than 180. So there can only be one obtuse angle in a triangle, and we already found it. So every other angle has to be an acute angle. Now typically what people will tell you to do is to use the law of cosines again, and that'll guarantee that your calculator doesn't confuse you. But because we've already found the obtuse angle, I'm not worried about my calculator confusing me. So we're just going to use the easier law of sines. And I'm going to use sine B because we found B, and of course sine A because we're looking for the measure of angle A. And we should probably put a divider here. So we're looking for the measure of angle A, and we know that the length of side A is 10. We just found capital B, which is 120. And before I forget, that should be a approximately equal to symbol. 120.25479 degrees. And that number should still be in your calculator. Over B, which is 20. So now all we have to do is multiply both sides of the equation by 10. So 120.25479 degrees. Sorry, we keep going off the page there. And so now we just have to calculate. So I'm going to push sine and then the blue button and then the negative symbol with parentheses at the bottom. Enter, and that allows me to put that in my calculator. If you're using an iPhone, you can just press the sine button, the regular sine button, not the sine inverse button. And then times 10, enter, and then divided by 20, enter. So sine is approximately equal to 0.43189 43189. And let's keep that in our calculator. So when we're looking for the measure of an angle, we use the sine inverse notation. And so the blue button, the sine button, the blue button, and then the negative symbol with parentheses at the bottom. That's how you keep that number in your calculator if you're using a TI-84 plus. And the measure of angle A is 25.58799 degrees approximately. And now we're going to find the measure of angle C. So of course we're just going to use the triangle sum theorem. And a lot of students will get angry that I'm carrying out so many digits here. So why do you have to carry out so many digits? Well, we're just making sure that we don't have a lot of round off error. So we're going to add 25.58799 to 120.25479. And then we're going to subtract that from 180. And there's many different ways to do this in your calculator, so be sure that you know how. And that should be an approximately equal to symbol. 34.157, and we're at the end of the problem, so I don't really care about carrying out a lot of digits there. So we've done 3 more problems, and we solved that triangle using the law of cosines. We could have used the law of cosines twice, but because we already found the obtuse angle, I don't have to worry about the law of sines confusing us. Okay, so now we have the SAS situation. We're going to use the law of cosines in that scenario. And notice that we haven't really had to worry about ambiguity. In the SSA scenario, you have to learn about worry about ambiguity. But whenever you use the law of sines, as we did here, to find the measure of an angle, you do have to worry about your calculator fooling you. But because we use the law of cosines to find the obtuse angle, we could then make a mental note that our calculator should always give us an acute angle. And we don't have to worry about the obtuse angle because we already found it. Okay, so we're looking for the length of side C, so we're going to use a different version of the law of cosines. And we're going to find the length of a side first instead of the length of an angle, or the measure of an angle, that is. So now all we have to do is use our calculator to simplify all that and make sure that you follow the order of operations properly. A lot of students have trouble with the order of operations here. 8.8 squared is 77.44. And 11 squared is 121. And you have 193.6. And then we're going to add 77.44 and 121. And we get 198.44. So we added all those to get that number there. And then we're going to multiply these to get this number. And maybe we should do that step by step just so we don't get confused. You don't have to do it step by step. But let's do that in the calculator. Cosine 128 is equal to negative 0.61566, and you're going to keep that in the calculator. So notice we have a double negative. And so we're going to multiply that by negative 193.6. And we get approximately 119.192. And you want to keep that number in your calculator. And this should technically be an approximately equal to symbol. Plus 198.44. And we get approximately 317.632. And again, keep that number in your calculator. And if you're using an iPhone, I believe the button looks like this that you're going to use. If you're using a TI-84 Plus, you want to push the blue second button at the upper left, then the X squared button, then the blue button at the upper left again, and then the negative symbol with parentheses at the bottom right. So it should say square root of A and S, and then press enter. So C is approximately equal to 17.8 222 centimeters. So we found the length of side C. So now we're going to find the measure of angle A. And again, you could use the law of cosines. But in this particular problem, we already know the obtuse angle, so we're not worried about our calculator giving us the wrong angle when we use the law of sines. The law of sines is probably easier to use. It's faster. And we have the measure of angle C, and we just found side C. And let's put a divider here. So the length of side A is 8.8, and the measure of angle C is 128 degrees. The length of side C is 17.8222, and you can keep that number in your calculator. And all we have to do is just multiply both sides by 8.8, and that gives us sine A, sine 128 divided by 17.82222, and then times 8.8. We get approximately 0.38909. We can keep that number in our calculators. And of course, A is approximately equal to sine inverse of that number. So we can do that on our calculator, and we get 22 degrees. 22.898 degrees approximately. So we have angle A. Now we can use the triangle sum theorem. to find the measure of angle B. So A is 22.898 degrees, and the measure of angle C is 28 degrees, or 128 degrees. And technically this is an approximately equal to symbol. So we can subtract 22.898 degrees from 180, and then subtract 128 from that. And the measure of angle B is approximately 29.1 degrees. So there you go. So we use the law of cosines and the law of sines in the ASA, actually the SAS situation. So if you got that one right, excellent. Okay, so now we're moving on to triangles where we don't actually have a picture. And so this means that this triangle might exist, it might not exist. This is the SSA situation, and you can draw a picture of the triangle if you're not quite sure which situation it would be. So we know C, and we know the side opposite C, and we know one of the other sides. It could be this side or this side, but we do know it's an SSA situation. It's not an SAS situation. If it were SAS, we could use the law of cosines. This is an SSA situation, so we need to use the law of sines. But the problem is there's some ambiguity involved with the SSA scenario. And if we use the law of sines, we might get angles that suggest there's no triangle, one triangle, or two triangles. So let's go ahead and try this. So on step 1, we're going to try to find angle A, or the measure of angle A. So we're going to use the law of sines. Sine A over A is equal to sine C over C. So remember, whenever you use the law of sines to find an angle, you have to be careful because your calculator might give you the wrong number. So we're going to solve for sine A. And using the calculator, 5 times sine 71 degrees. Enter, and divided by 6. And we get approximately 0.78793. And now we need to find the angle, so we need to press this button in the calculator. And we need these numbers to stay in our calculator. And I get A is approximately equal to 51.9927. Actually, I'm not going to round up. We'll just say 9926 degrees. Let's keep that in our calculator. But be aware that there's more than one solution to this, so we need to be aware of that. And the first thing we need to do is add this angle with our original angle and make sure that the sum is not greater than 180 degrees, because if it is, we have a problem. That means there's actually going to be no solution. So we need to see if C plus A is less than 180 or not. So C is 71 degrees. A, we just found, is approximately 51.9926 degrees. And if we add those up, we get 122. So that means that there's at least one triangle, and we don't have to find the or carry out so many decimals there. So I'll put a check by that. And now, remember, we can have a triangle in the first quadrant with an angle that's equal to 51. So we got a triangle in the first quadrant and a triangle in the third quadrant, and the reference angles are 51.9 degrees approximately. And this second angle would be 180 minus 51.99268. That would be 128.007 degrees. So if we add that red angle to C, we need to see what we get. So let's add that red angle, 128.007 degrees plus 71 degrees. And we're just showing the work here, but you can see obviously that that's not gonna be a correct inequality, because we get 199 degrees approximately. That's not less than 180. So that means that only the acute green angle here, 51.9 degrees, is going to work. So that means we have one triangle that's possible. So now that we have our angle here, angle A, we can find the rest of the information. So part 2 is to find the measure of angle B. And we can use the triangle sum theorem. Measure of angle A we found is 51.9926 degrees. Measure of angle C is 71 degrees. So subtract 71 from 180 and subtract 51.9926 from that result, and we see that B is approximately equal to 57.007 degrees, and that's approximately equal to, and so we've got angle B. Now we just have to find side B, the length of side B. So we're going to use sine B over B is equal to sine C over C. We want to use sine C because we were given that information. We don't have to round off. So sine 57.0074 degrees over the side length that we're looking for is equal to sine 71 degrees over 6. And if we do the math, technically that should be approximately equal to, we have 6 times sine 57.0074 degrees over sine 71 degrees. So if we enter that into our calculators, we get approximately 5.322 inches. So that was an example where we had one triangle. We had to check to make sure that we didn't have two triangles, or that we didn't have no triangle possible. So we didn't really need to use this space over here. And we can include one triangle. Kind of circle that. Okay, on to number 20. So again, we have the same situation, and you can try this problem if you want. We have the SSA situation. There's ambiguity. We could have no triangle possible, one triangle possible, or two triangles possible. So you can try this if you want. You're going to use the law of sines. But remember, you have to make sure that sine A, or the value of sine, whatever the angle is going to be, A, B, or C, we have to make sure that sine is not greater than 1. We also have to make sure that the sum of these two angles is not greater than 180. If the sum is not greater than 180 for the first angle, that means there's at least one triangle. And if you find the angle in the second quadrant and add it to the first angle that they gave us, and that sum is still less than 180, then you have two triangles possible. So I know that's a lot to take in, but try number 20, and when you come back, we'll do it together. Okay, we're back. So we're first going to try to find the measure of angle A using the law of sines. So we're looking for the measure of angle A, and we know the length of side A. We know the measure of angle B and the length of side B. So sine A is approximately equal to 51 times sine 22 degrees over 16. And we can enter that into the calculator. And sine A is then approximately equal to 1.194. And at that point we can say that that cannot be true, and there's no triangle possible. How do we know that? Because it's impossible for the sine function to be greater than 1. Remember, sine oscillates back and forth between -1 and 1. So if it's greater than 1, then that's impossible. There is no triangle that fits this description. So if you got that right, excellent. Okay, so again, we didn't need that extra space there. Try 21. We'll see what happens with 21. Again, there might be no triangle possible, one triangle, or two triangles possible. When you come back, we'll do it together. Okay, so we're going to try to find the measure of angle C using the law of sines. And again, whenever you use the law of sines to find the measure of an angle, you have to consider the possibility that the triangle may not exist, or your calculator will give you the wrong number, or there may be two triangles or one triangle possible. So we're going to plug in the measure of angle A, and we have this length of side A. And we're looking for the measure of angle C, and we have the length of side C. And now we're going to multiply both sides of the equation by 30. And now we need to go to the calculator. 30 times sine 146, enter. And divided by 26, enter. So sine C is approximately equal to 0.64522. We can keep that number in our calculator. and we want to find the measure of angle C using the calculator. We get approximately 40.18 to 3 degrees. We can keep that number in our calculator. And we need to compare that with the original angle. And you see, when we add the measure of angle A, which we were given, and the measure of angle C, that's actually going to be bigger than 180 degrees. So we tried our first number the calculator gave us, and that number didn't really make any sense. So in this case, there is no triangle possible. So there's two situations that you're going to come across when there's no triangle possible. One situation is sine is going to be greater than 1. In this case, it was not greater than 1. But when we found our acute angle and tried to use it with this angle, we added those numbers up, the measure of angle A and the measure of angle C, and the result was a number that's greater than 180 degrees. So we see that that's impossible. So those are the two situations where there's no triangle possible. So we have one more of these problems. Again, we have the side angle SSA scenario. And see what you can do on this problem. You want to find the angle, make sure that when you add it to the original angle, the sum is less than 180. You want to make sure that sine B is less than 1. And if those situations are true, then you'll either have one triangle or you'll have two triangles. So you'll have to check the acute angle for B that your calculator gives you, and also the obtuse angle that terminates in quadrant 2 for B. So try number 22. When you come back, we'll do it together. So we're going to find the measure of angle B using the law of sines. And now we're going to multiply both sides by 18. And we can use our calculator. And we get 0.203. Actually 208. 7, and we can keep that number in our calculator. And B is equal to sine inverse of that number. So let's calculate that, and we get 12, approximately 12.027 degrees, and we'll keep that number in our calculators. So now we want to know if this number works with this angle here, and if you add those up, you get a number that's much less than 180. So we know that this works. So 10 degrees plus 12.02, so on and so forth, is less than 180 degrees. So we can put a check. So that angle works, and that is definitely an angle as part of the solution. But now we need to look at the angle that terminates in the second quadrant. If sine is positive, then you can have another triangle in the second quadrant. And as we know, the reference angles are the same, so 22.02 degrees. Actually 12, sorry. 12.02 degrees. And then this other angle is 180 minus 12, which is 167.97 degrees approximately. And if we add that number, well, we'll call this B1. If we add B2 to C, the question is that going to be less than 180 degrees? So 10 degrees plus 167.97 degrees. If that's less than 180, then we'll have another triangle that's possible. And we get 177.97 approximately, so that works. So that means we have two triangles. Let's create the first triangle, or find the missing numbers for the first triangle. So step 2 is to use the triangle sum theorem. We'll find the measure of angle A. And you don't have to write this. You can actually do the math in your head. So C is 10 degrees. B is approximately 12.02. And that number should still be in your calculator. 12.0273 approximately, and we're looking for A. We're going to subtract 12.0273 from 180 and subtract 10 from that, and we see that the measure of angle A is going to be approximately 157.97 to 7 degrees. So we have another angle. Now we just have to find the missing side, and we'll call that A1 and B1. So now we're going to find the length of A, and we can put a divider. Sine A over A is equal to sine C over C. We want to use the C's because those numbers are not rounded off. And we have sine of 157 .9727 degrees over A. Solve for A, and you don't have to show the math. That's going to be 15 times sine 157.9727 degrees over sine 10 degrees. And by the way, this should be an approximately equal to sign up here, and approximately equal to here and here. So now let's do that in our calculators. And we get 32.3, oh, we can just say 32.4, and that's millimeters. And we'll call that A1. That's for the first triangle. So now we're going to use this other angle we found, 176, B2. And we're going to go up here and assume that B2 is approximately 167.97. Let's carry out some other decimals. Say 9 degrees. So now we can go to step 2 of this problem, which is to find the measure of angle A2 using the triangle sum theorem. So A2 plus B2 plus, now we're going to call it C2, and we can call this C1 over there. Well, actually there's only one C, so we don't really need to call it C2. We know B2 and C is always 10 degrees. That doesn't change. A2 is what we're looking for. So now we can just do the math. 180 minus 167.97269 and minus 10. And the measure of A2 is approximately equal to 2.0273 degrees, and we can keep that number on our calculators, and technically this should be approximately equal to, I always forget that. So that is one of our angles that we're looking for. And now we just need to find the side length, which we'll call lowercase a2. Find A2. So we're going to use the law of sines, and we're going to plug in A2 and sine C over C. C is the same no matter what because that number doesn't change. That's written in stone. The length of C is 15 millimeters. We're given that. And A2 is 2.0273 degrees. If we solve for A2, and that should be an approximately equal to symbol, we get 15 sine 2.0273 degrees over sine 10 degrees. So let's do that math in our calculators. And A2 is approximately equal to 3.0558 millimeters. And that's it. So these numbers represent the missing numbers for the second triangle. That's why we call them B2, A2, and A2. And these numbers over here represent the missing numbers for the first triangle that's possible. A1, A1, and B1. So you don't have to have different colors. Okay, let's try number 23. We don't really have time to show all the different transformations, so as long as you have the equation of the midline and the period and the phase shift, you should be able to graph without really going through every single step. So go ahead and try number 23. When you come back, we'll do it together. Okay, we're back. So this is the equation of the midline. Y equals 2. And the period is the normal period for secant, which is 360 degrees, divided by omega, which is 1/2. Omega is the coefficient of x. And if you simplify that complex fraction, you get 720 degrees. The phase shift is always phi divided by omega. And maybe I should write that equation there. That's 360 divided by omega. Probably be good to show that. And phi divided by omega, that's going to be positive 180 degrees. Remember, it's the opposite sign, so it's negative up here. That means it's positive phi divided by omega. Simplify that complex fraction and we get 360 degrees. So now we're ready to graph, given that information. So the phase shift is 360, so we're going to start where our curve usually starts. Our curve usually looks like this, something like that. And we're going to move 1, 2, 3, 4 units to the right. And with the secant curve, well, first of all, let's think about the period. So 1, 2, 3, 4, that's where we start. I want to mark that. And then the period is 720, so that's going to be 8 boxes, because each box is 90 degrees. So 1, 2, 3, 4, 5, 6, 7, 8. So our pattern is going to go all the way to there. We usually divide these graphs into 4 parts. But because we have 8 squares, 2 squares is going to be one of those parts. So that means our asymptote, our first asymptote that is going to be there. And our midline equation is y equals 2, so that's going to be this line here. And make that a little bigger. So that's that line there. And our graph is going to look like this, but you see the negative here. That means we're going to reflect. Everything's going to be flipped the other way. So the graph is actually going to go down like this. And then it's going to go in a U shape up like you see here. And we're going to have another asymptote. And then we're going to have another curve down here. So if your graph looks something like that, good job. That's good enough. Okay, go ahead and try number 24, and when you come back, we'll do it together. Okay, we're back. Y equals 1 is the equation of the midline. We get that from this number. The period is the normal period of sine divided by omega. And omega is 1/3. If we multiply and simplify the complex fraction, we get 1080. So that's the new period. And the phase shift is phi divided by omega. Phi is negative 90 degrees. Remember, it's always the opposite sign. Divided by 1/3, that's omega, is 1/3. If we simplify the complex fraction, we get negative 270 degrees. And the amplitude is the absolute value of 3, which is 3. So given this information, we can graph this this equation. So let's draw the midline first. Y equals 1, that's the graph of the midline equation. The phase shift is negative 270 degrees, so we normally start our curve there. But we're going to go to the left 1, 2, 3 boxes. That's 90 degrees times 3 is negative 270. So looks like we're going to start somewhere around there. And the period is 1080. And if we divide 1080 by 90, we see that it goes in 12 times. So there's going to be 12 boxes for one complete cycle. And if we divide, again, these equations, the sine, cosine, cosecant, and secant equations are divided into 4 parts. The cotangent and tangent functions are divided into 2 parts when you graph them. But since there's 12 boxes, we're going to divide each part of the graph into 3 boxes. And the amplitude is 3, so I have to go all the way up to 3. So the first 3 boxes are going to be the first part of the graph. So it's going to look something like that. And then like this. And then we're going to go down to here. And then back up to here. And we really don't have to graph anymore. We can if we want to. So if you got that right, good. Okay, on to the next problem. Try number 25. When you come back, we'll do it together. Okay, we're back. So the equation of the midline is y equals negative 2. The period is equal to the normal period of the cotangent curve, which is 180, not 360, divided by omega. And omega is not a fraction this time, it's just that 2 there. So we got that from there. And so the period is actually 90 degrees, so the period actually got smaller in this problem. The phase shift is equal to phi divided by omega, and phi is not positive 360, it's negative 360. Remember, you have to change the sign. In the first problem, it was a negative number, so we had to change it to a positive. So negative 360 divided by omega, and we get negative 180 degrees for the phase shift. So normally our cotangent curve looks something like this, but we have a 180 degree phase shift, so we're moving everything to the left 180 degrees. So let's draw the asymptotes. That actually doesn't change the look of the graph at all when you move it over, because if you move this shape over here, then it's really the same thing. But we're going to move everything down 2 units because the midline is down here, and we don't really need this asymptote. And the period is 90 degrees, so that's definitely going to change things. So it looks like we had a horizontal compression. If the period is 90 degrees, then one box is going to be a complete cycle. So it looks like our graph is going to look something like this. There's a complete cycle in one box, and that means that there's going to be an asymptote on every vertical line in the grid. So again, you only have to draw one cycle. So that is one cycle. Let's make sure we did everything correctly. We moved down 2 units. The period is only one box, 90 degrees, and the phase shift is negative 180, so we moved over 1, 2 to the left. So if you got that right, good job. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. So you can get a screenshot of all this information here. Here's a screenshot number 1 of the practice test, and number 2, and number 3, and number 4, and number 5, number 6, seven, 8, 9, and 10. But don't go before you get your homework. The homework is a practice test, as I mentioned. This is practice test 3 version 2. So go ahead and get a screenshot of that. Screenshot number 1 and number 2 and number 3 and number 4, 5, 6, 7, 8, 9, and 10. But don't go before you get the answers. Here's the answers for the practice test. Remember, it's not enough just to attempt the test. You have to do it completely and correctly. So here's the answers for problems 1 through 20. And here's the rest of the answers. So get that practice test done completely, correctly, neatly, and keep it in order in your binder. And remember, completing this practice test is the absolute minimum that you need to prepare for the test. But if you want to get a really good score on the test, then you need to go back and study everything that we did up to this point in the course, but especially this information, and of course you need to memorize all of it also. So that said, I'll look forward to seeing you in the next class.